All right, so today's lesson is on topic 2. We're looking at the wheel and axle, we're looking at gears as well as pulleys. Today we'll focus on the wheel and axle and the gears. All right, so just in this diagram, what we're looking at is that sometimes levers, they're not practical to use, right? If you're trying to lift up this elephant, it's not a good idea to try and do that with a lever. So we do have to go and look at some other simple machines. So the first one we're going to look at today is the wheel and axle. So I do have a video here to show. All right, so here is an example of a wheel and axle device. This is called a winch. And I do have another video I'll show later on the winch. So basically this winch here is being used to make loading a boat onto a trailer much more easier. So it consists of a small cylinder. So you got the cylinder here, then it's got this crank or handle. The axle of the winch, it's held in place and it acts like the fulcrum. So right here is the fulcrum. And then the handle is acting like the effort arm of a lever. So when we exert force on the handle, it's going to turn the wheel, similarly like the effort force on a lever. And then this radius here of the wheel, it's acting like the load arm of a lever. So then the force that the cable exerts on the wheel is like the load on a lever. All right, so there's the cable right there. Here are some more examples of the wheel and axle. So it's a machine consisting of two turning objects and they're attached to each other at their centers. So one object causes the other to turn. So like a doorknob, steering wheel, here we have like a gauge. All right, next we're going to look at gears. So think about like a clock, like a grandfather clock or something. It has a second hand, a minute hand, and an hour hand, and each of those are rotating at different speeds from the same point. So how is this done? It's done using gears. Okay, and then the gears are put together so that one wheel is able to rotate faster than another wheel. So a gear, it's a rotating wheel-like object, and it's got teeth around its rim. Let's see if I have a diagram here. So this would be like a gear, right? And those structures on the outside are called the teeth. So a gear train, this is a group of two or more gears. So like this, there's two, that would be a gear train. Here, there's 3 gears, that would also be a gear train. So it's a group of 2 or more gears. And what's happening with gears and a gear train is you have the teeth of one gear, they fit into the teeth of another. So look at how the teeth here, they're fitting in together. And so when the first gear turns, its teeth push on the teeth of the second gear, which causes the second gear to turn as well. So the first gear is called the driving gear, or it's called the driver, and it may turn because someone is turning a handle, or maybe it's attached to a motor. The second gear is called the driven gear or the follower. Okay, so driving gear is the one it's attached like a handle, or because it's attached to a motor. The second one is called the driven gear or the follower. All right, so here, this one would be the driver gear. It's got the handle, so somebody would be turning that. And then the follower gear is this one. Okay, and now notice with these 2 gears is the rotation is in opposite directions. So this driver gear is being turned clockwise, the follower gear is turned counterclockwise. Just some more examples where gears are used. Here we have a combine. In farming, it uses sprockets and belts and gear trains. This is inside an old-fashioned clock. So again, gears are used to make sure the minute hand, hour hand are turning appropriately. Here it's in looking at a large telescope. There's also gears inside the large telescope to track the stars and so on. Can one gear turn another gear without touching it? We can see this happen in bicycles. So one set of gears is attached to the pedals and another to the rear wheel. And then we have a chain like this here, a chain connecting the gears, and that allows the front gear to turn the gear on the rear wheel, and it's some distance away. A sprocket, this is a gear with teeth that fit into the links of a chain. All right, so that's what a sprocket is. So here, when we have wheels or gears in contact, again, notice the rotation is in opposite directions. Okay, so one advantage of this here is in image A, the gears are turning in opposite directions, but here, notice when we're looking at the chain and sprockets, they're turning in the same direction. They're both turning in clockwise direction. All right, so that would be an advantage of using the sprockets and the chain. Okay, next we're going to look at speed ratio. It's a calculation. So first, each link of a bicycle chain moves the same distance in the same period of time. So basically, if the front sprocket moves a chain equal to 45 teeth, the back sprocket is also going to move a distance of 45 teeth. However, look at the sizes and the numbers of teeth. The back sprocket may have only 15 teeth. The front sprocket may have 45 teeth. So as a result, the back sprocket is going to make 3 full turns for every 1 complete turn of the front sprocket. All right, and that's where we get into this speed ratio calculation. It's the relationship between the speed of rotations of a smaller gear and a larger gear. Okay, and then we can make this calculation using the number of gear teeth. So it's the number of driver gear teeth divided by the number of the follower gear teeth. So if it tells us here, the front sprocket has 45 teeth, the back one has 15 teeth. So 45 divided by 15 is equal to 3. So therefore, this bike has a speed ratio of 3. Okay, just going to pause it here. Okay, so today's lesson we are going to look at pulleys. So a pulley, it's got a wheel. The wheel's got a grooved rim, and basically there is a rope or a chain inside of that grooved rim, and it's there to guide that rope or chain that'll run along the groove. So it's used to transmit or change the direction of force. So think about like blinds, you can pull the blinds, it changes the direction of force. It's similar to a class 1 lever, but instead of a bar, a pulley will have a rope. The axle of the pulley acts like the fulcrum, and the 2 sides of the pulley are the effort arm and the load arm. All right, so here, this is called a fixed pulley. So it's attached to something that doesn't move, so it'll be attached to something like a ceiling, a wall, or a tree. Another example would be like a flagpole. So all that's happening is we're just changing the direction of the effort force. So when you're pulling down on the effort arm, so you're pulling down here with the rope, the pulley will raise the object that's attached to the load arm. All right, so this is what is attached. So a single fixed pulley, it simply will just change the direction of the motion, and it makes certain movements just more convenient. So once the flagpole pulley is attached, you can raise and lower the flag. All right, so again, it's not changing the amount of force applied, it's just changing the direction of the force. Okay, this has got a mechanical advantage equal to 1. This is an example of a movable pulley. So this time a pulley is attached to something that's movable, such as a construction crane or an oil derrick. So this type of movable pulley, it increases the amount of force applied. It does not change the direction of the force. So like if a rope is fixed to the ceiling, then it comes down around the pulley and back up, you can lift and lower the pulley itself by pulling on the rope. And then the load, it may be attached to the center of the pulley. So here is the load, center of the pulley. So let's just pause and watch this video on mechanical advantages of pulleys. All right, next we can see how combinations of pulleys can be used to lift very heavy or awkward loads. A compound pulley, it's a combination of several pulleys working together. So like we saw in the video. This one's a type called a block and tackle, like used in oil pumps. They use several pulleys and a lever to raise and lower the pump valves, just to grab that oil and bring it to the surface. So this one here, it's got 4 pulleys. It's got a mechanical advantage of 4. Another example is a block and tackle. It's a combination of fixed and movable pulleys, again, to lift heavy or awkward loads. So this one has the fixed pulley and then also a movable pulley as well. This one is showing a mechanical advantage of 3. All right, so last we're going to watch this video. It's going to take a look at levers, pulleys, and gears, how they work, and also looking at mechanical advantage.